Hi guys, I'm Mahmoud Mokhtar, studying at Cairo University, Faculty of Computers and Information, and I'm taking CS 214 Data Structure course with Professor Mohamed El-Ramly. And in this video, I'm going to talk about recursion. A lot of people find recursion a confusing topic, when it's actually an easy one if you wrap your mind around it. But before going through recursive functions, let's define recursion. If you looked up in the dictionary, you'll find out that recursion is the process of doing a procedure repeatedly. Okay, but what's the use of recursion in programming? Well, coding is an art, not just writing codes, compiling and running them. Like you can solve the same problem in so many ways, but we as programmers like to see elegant and good ways for solving problems. Recursion helps in writing code which is elegant and easy to understand. A recursive function is a function which keeps recalling itself multiple of times, like repeating the same process over and over again. Sounds complicating, right? Let's take an example. Let's take the factorial function as an example. Recall from your math class the factorial function which equals to the product of multiplying all positive integers less than and equal to n. For example, factorial of 4 is 4 times 3 times 2 times 1. You get the idea. As programmers, we will define the factorial function as fact of n. This is how we compute factorial. Notice that factorial of 1 equals 1. In other words, we can write the factorial function in this way. Factorial of 2 equals 2 times factorial of 1. And factorial of 3 equals 3 times factorial of 2. See, we can compute the factorial by invoking the same function but with different parameter or input. Now to generalize, we can say that factorial of n equals n times factorial of n minus 1. This is how we can define the factorial function recursively. When you define a function recursively, two things need to be part of it. The first thing is the base case, which when triggered, it will stop the recursive process. As you can imagine, a recursive function without a base case or stopping condition, it can go on forever. If we don't have a way to stop a recursive function, we will be stuck in infinite loop, and the program will crash because the computer might run out of memory. Second, the recursive case, where the recursion will actually take place. This is where the function will call itself. It won't call itself the exact way it was called before. There will be a slight variation that will make the problem we are trying to solve a bit smaller. Which one do you think would be the base case? Factorial of 1 would be the base case because it's the simplest computation. It doesn't need anything special. And factorial of 1 result is actually known, so it would be a good decision to make it the base case in order to stop the recursive process. So, for defining our factorial function, here's a skeleton for how we might do that. We need to plug in these two cases. The base case will be if n equals 1, return 1. That's a really simple problem to solve. So this will be our base case. So what's the recursive case probably look like? For every other number besides 1, what's the pattern? Well, if we are taking the factorial of n, it's n times factorial of n minus 1. And so if we are not looking at 1, otherwise return n times factorial of n minus 1. See, we are making the problem smaller. If n starts out as 3, we are going to return 3 times factorial of 2. Then factorial of 2 will return 2 times factorial of 1. And see, we reached 1, our base case, so the recursion will terminate. Once hitting the base case, the function can compute the result. As n equals 1, factorial of 1 will be 1. And so factorial of 2 equals 2 times factorial of 1, which is 1, and the result will be 2. Then factorial of 3 will be 3 times factorial of 2, which is 2, and the result will be 6. A recursive function can replace a loop in a non-recursive function. So here side by side is the iterative version of the factorial function. Both of these calculate the same thing. The version on the left uses recursion to do it, and on the right uses a loop. So these two functions do the same thing, but in different ways. A recursive function can have more than one base case or a recursive case, depending on the problem you are trying to solve and on the input being passed. There are 3 key points you need to remember to be able to make recursive functions. First is the definition of a recursive function, which is a function which calls itself multiple of times. Second, any recursive function must have a base case in order to terminate. Third, any recursive function must have a recursive case to go through the function over and over again. Let's take another example. Fibonacci series is a series which starts with 0 and 1. Then each next element is the sum of the two previous elements. As you can see, 0, then 1, which is 0 plus 1, and the next element is 2, which is 1 plus 1, and so on. Now, how to recursively compute the Fibonacci of a number? Well, the Fibonacci of element index 0 is 0, and Fibonacci of index 1 is 1. See, they are easy and simple to solve, so we can make them our base cases. Otherwise, any number greater than 1 and 0 will be the sum of its previous two elements in the Fibonacci series. Let's put this into codes. First, let's set up our recursive function skeleton. Of course, it has a base case and a recursive case. Now let's fill in the comments. As you can see, we have two base cases. It is normal. Any recursive function can have multiple base cases or recursive cases, depending on the problem you're trying to solve. Now, the base cases are: if n equals 0, return 0, and if n equals 1, return 1. Otherwise, return the sum of the Fibonacci of n minus 1 and n minus 2, the two previous elements. See how recursion can make problem solutions less cryptic and easy to understand. There are many countless other implementations and uses for recursion. Here are some other examples. First of all is binary search. Binary search algorithm helps you to find an element in an array or any other container. In order to use binary search, an array or else must be sorted. Second of all is Towers of Hanoi, which is a puzzle game. You can find a solution for this puzzle easily using recursion. Third, the GCD. Recall from your math class something called greatest common divisor, which is the largest positive integer that divides a set of numbers without remainder. GCD calculation using recursion is quite easy too. You can search for these and other implementations of recursion on the internet. It will be easy to understand as long as you understand the concept of recursion. I hope you found this video informative. My name is Mohamed Mokhtar, and thank you for watching.